couple of things. If you saw the poster earlier on, it had 2 C's. That's a phonetic spelling, but the name is actually spelled with 1 C's. More importantly, the Twitter handle is with 2 zeros. Valboo is pronounced, but it's Valb00. I'm really thrilled to see actually such a social media engaged event here. You don't often see that every day. I'll do a quick poll of my own before we even get to the slides, actually. How many of you are on Twitter? Show of hands. It's actually pretty good, some of the best representation I've seen. I don't want to be a downer, but if you're not on Twitter, it is a career-limiting move in tech nowadays. I follow about 3,800 odd people. I learn so much from my Twitter feed. I curate it manually. I look for startup technologies, new technologies, and so forth. It's a wonderful way to stay abreast and ahead of technology. It's not just about what I had for breakfast or dinner. It's easy to belittle it, but there's a tremendous amount of value in it. So if this is forward progress, let's move on. Imagine if you're blind. Hopefully you don't have first-hand experience with that, but if you do, imagine if all of a sudden you get a really important medical prescription, but it's not in Braille, so you can't read it. You can't take your critical medicine. There's something more fun. It's your birthday, it's Christmas. You got a really cool gadget from a friend, delivered by Amazon. You want to whip open a box, look at the instructions maybe, and actually get this thing going. They're not in Braille, so you can't read it. A gentleman by the name of Ray Kurzweil, who some of you might recognize, seized upon this opportunity about 30 years ago now, in the mid-'80s, and delivered effectively the first iPhone-like device, the first handheld device that ran a single app, hardwired single app. And that app was to read OCR text, black print on white paper, and actually speak it out loud through a speaker, built-in speaker, for visually disabled people that needed to be able to read regular printed instructions. Really revolutionary technology, considering what was incorporated in the form factor for the mid-'80s. And so Ray became independently wealthy and became obsessed by what was the history and what is the future of this reference form factor, this handheld computing cloud device, I think you're saying, Rob, right? So he plotted, he started a whole movement called the Singularity Movement based upon this, but he plotted this one really instrumental chart. It dates back to technology advances all the way in the Industrial Revolution, going forward to today and forward. And here's a really difficult part for humans to grasp. The conclusion, if you can obviously see this slide, is that technology doesn't progress linearly, the way we intuit it does as humans. Technology progresses exponentially. That math is profound. And I can't imagine a better lead-in than Matt's lead-in just the session prior to it with regards to some of the changes that are upon us in this industry. Because of the relentless pace of exponential progress, I'm going to share some things with you that you will not believe. But try and at least understand exponential math and how in one purchase cycle, 4 years from now, things are going to be fundamentally, 2 to the 4, better. In 8 purchase cycles, even more so, compound doubling, the exponential part. And if you believe in that math finally, you might lend some credence to what I'm about to tell you. A couple of specific projections, and Ray now, kind of scary, he decided to work at Google because they have virtual unlimited resources, so he's able to implement a lot of his plans into action. He projects that today this single handheld form factor, and today is actually a bit of a milestone day because if you're reading your Twitter feed or some other feed, you know that Apple had their major launch this morning and the iPhone 6S is upon us. The 6S Plus or Plus S, I'm not sure what the order is upon us. So we're seeing major advances in the processing power of that technology. Ray predicted that already we're ahead of insects and rodents in terms of the brain power. So he measures synaptic capacity of this device. The raw brain power is already ahead in that reference form factor, that iPhone 6S, of some pretty important animal types that we actually do a lot of medical experiments on, like rodents, mice. The mind blower now is in 2 purchase cycles, 7 years or less. 2022, Ray's math predicts, and this will be more important than Moore's Law pretty soon, that a single iPhone, a single handheld device, will have more raw brain power, more raw synaptic capacity than a full human brain, fully developed human brain. So the era of AI is completely upon us as of 2022. And Ray speaks at Davos conferences and other prestigious events. At the last Davos conference, in the winter, I guess, he pulled in a projection now. By 2042, 2042, that single handheld device will have the raw brain power of all the human brains on planet Earth. This is exponential progress, folks. And this is the pace we're on with technology improvements. So I kind of like to joke with a lot of neighbors, friends, nieces, cousins. If your daughter, your neighbor, your nephew is going into a BA philosophy degree and you want to belittle him or her, the single most important degree in the future is to explain what is a soul. Because the raw brain power to create sentient things is upon us in 2 purchase cycles. Affordable, convenient, mobile. The raw brain power is already in Google's data centers today, if you've read about their computers and the dreams they have. Fascinating read. I love the third platform, by the way. My life is all about the third, and increasingly now with IoT, we're calling it the fourth platform. Another term that customers have used and some analysts also refer to is smack talk. This clearly resonates well with North American audiences, not so much in Europe and Asia. I often present this to IT departments. So Matt talked about the difference between IT and lines of business. And a lot of heads nod, even today. That's kind of my adoption inside my enterprise for these respective technologies. This is a 3-year-old chart. So remembering exponential math, all of these are at 100% today. Either shadow, stealth, or real IT. They're all in your enterprise today. And what that means from a storage and data management perspective is we have fundamentally new data models that we have to capture, manage, protect, have governance rules for, secure. Lots of work needs to be done with all these new, cool, scale-out third platform workloads. So let's walk through one example here. What does that mean? What is a third platform application? Really important to understand this because this is not what I was taught in college. And this is not what a lot of the generation of sort of IT leaders now, the millennials' parents, if you will, they weren't taught this in college as well. And FYI, in case you didn't catch the headline a couple of months ago, according to the U.S. Department of Labor, as of a couple of months ago, millennials, these are people that graduated in Y2K, now are the majority, the small majority, but the majority of the workforce. 34% are millennials. So their expectations, as Matt said, of technology are very different. Here's what an app that we all use that was designed by millennials looks like. It's a common Amazon page where we do a lot of our purchases. And it's laid out, and a couple of the key elements, the data models that we have to focus on is more than just one, of course. The rich media, the videos, some of the audio clips, pictures, and so forth that we store on this page are typically in object databases. I could have used Amazon's S3 example here, of course, which literally has defined the object storage market and continues to define it. I believe the last time they even bothered boasting, they were at several trillion objects managed globally by S3, having up to 11 copies of those several trillion each. And I can't even count the number of exabytes of capacity that S3 manages today. It's a phenomenally impressive, scalable system. A simple open source alternative. If you want to develop this part on your laptop and you're not connected, it'll be something like Ceph, built into Linux distributions. But wait, there's more. So your session, your actual cart for rapid responsiveness is managed by one of several key value NoSQL databases. This one, a very popular one, is Redis. Redis is a database. Redis has also become a de facto interface for transactional key value, get put type operations in memory for responsiveness and performance. I like to joke the single most boring part of a third platform application is that relational database that we all do know and understand. And that's the one that, of course, stores some of the most important financial information, but it's not considered sexy or interesting by the developers at all. On the other hand, we're up to 4 now. 4, at least an average of 4, fourth kind of data store that's managed in a single application, and that's a graph database. How many people have experience with graph databases? This one's new-ish. This one is where you have records, like people and objects, the relationship, who owns what object, who paid for what object and when, how much was paid. The relationship between those two objects is the first-class record, the first-class object in a graph database. So, of course, when you see other people also bought on Amazon, Or Netflix, also people also watch that we recommend the following movies for you. On Facebook, you should be adding these friends. On Twitter, you should be following these people. On LinkedIn, this person's also connected to these people. That is all graph database technology. It's not a conventional database technology. Very intensive in-memory database, and I'll get to that trend a bit later as well. What point? Number 5, you're at the airport. You build an elaborate cart of 10 objects. You're about to click checkout. The crappy Wi-Fi dies at the airport. You're mad. You've got to rebuild that whole cart again. You've got to go through that convoluted workflow. If the application was coded properly, there's a complementary key-value database known as REAC. And that's more focused on persistence in memory. So less on performance, more on recovering from those unfortunate error conditions that we all have to contend with. And again, it's a sign of a maturity, the maturity model for an application, that it understands all sorts of error conditions and can recover gracefully from them. Finally, for those of us old enough to remember Lotus Notes, MongoDB is the modern version of Lotus Notes. It's a way to lay out this form as a simple set of objects on a form. You don't have to do this awkward object to relational mapping that we've had to in the past. And Mongo is phenomenal as for an example of how far simplicity will get you. This database from nowhere about 4 years ago shot up to be one of the top 3 popular databases in the world in such a short span because it dramatically simplified the process of creating forms, which almost every business process needs now. Create some simple forms. Also open source. And you'll notice that analytics-style big data databases like Cassandra and the whole Hadoop ecosystem, that's almost the least interesting part of these apps to modern developers because they're relatively mature in their world. Hadoop is not new to this generation of developers. Cassandra, the DynamoDB, and Amazon is not new. This is an average composite of what constructs a third platform application. 7 different, sometimes fundamentally different data models to manage in a consistent way, to protect, to scale, to add auditing and governance to. There's a lot of work for IT ahead of us as a third platform emerges. Now, the obvious part for a storage and data management vendor like NetApp is, so how do we manage all these new and different kinds of workloads that are no longer the traditional relational database or file system workloads? I'll get to that. But one of the things that's really important to understand is there are always unintended consequences of a shift like this. And the main unintended consequence of this shift is what's happening to our own supply chain. So let's now start with, I guess, our first polling question, because I will be talking about the influence of all these hyperscale data center architectures. Do these hyperscale computing environments influence your own data center architecture? And you get to choose between a bit more than yes and no. So A is often, B is the middle one in between sometimes, and C is rarely. And let us see if people can text. I know personally I actually struggled with getting AT&T service in this room, so if you're on AT&T, that's your excuse for not texting. But Verizon people, T-Mobile people, Sprint people, time to step up. So the middle of the road answer, it's kind of what I expected, but there's definitely some pioneers out there, and there's also some laggards. And I'm not trying to be pejorative, but when you lag in innovation, you ultimately will lag in competitiveness as a business, so that's something to be wary of. Here's how we map out the supply chain. An XY chart, very much like Matt's, so pretty traditional Y-axis, it grows and things get more expensive, but the X-axis, things get slower because we're measuring the growth in latency or access time. And 2 endpoints we don't traditionally see in a storage discussion: memory, DRAM, and tape. But we do have that all-familiar legacy disk drive, enterprise class, high RPM, fiber channel or SAS interface disk drive. And the first thing to realize is the first unintended consequence of the popularity, the overwhelming popularity of these third platform applications is that we, NetApp, and our peers, EMC, Hitachi Data Systems, and so forth, within about one more purchase cycle of about 4 to 5 years at most, will not have this drive from our supply chain to sell to you in our storage arrays. The enterprise disk drive is becoming as much of an oxymoron as the performance hard disk drive. You just don't do performance with mechanical disks anymore. Why, and where is it going? Some simple facts and figures, and hopefully Matt's data correlates with this. This is a correlation of several analyst reports. One study was recently published trying to capture a particular organization's spend. And I like to joke now, you've all used this today several times just getting into this room. Its name is Alphabet, if you kept up with the headlines. And that's code for Google. Alphabet is a parent company of Google. $3.5 billion is not their full technology spend even, because it doesn't include data center costs. The real estate, the huge power and cooling operational costs, or the staff costs, which are typically minimal in these highly automated data centers, that is not included in this figure. What is included is the compute tier, CapEx, the memory tier, which is distinct at Google, the network tier, which glues it all together, and of course the storage tier. Those 4 tiers alone have a CapEx at Google of $3.5 billion with a B. I'm glad you're all sitting down because that is a quarterly figure. We're beginning to understand the major shifts in the sand here. You add in Facebook, Alibaba, Ali with or without, Amazon with or without AWS, Microsoft with or without Azure. Pretty soon you're getting at about, if I do it right, $50 billion in CapEx for next generation third platform workloads. Any one of those, Google alone, Alphabet alone, purchases more disk drives than NetApp, EMC, and Hitachi combined. So if you are Seagate, if you are Western Digital, or maybe even Toshiba, who do you orient your roadmaps to? People with all the dollars or people with less dollars? Of course. And by the way, all of us in this room are the people with less dollars. Our workloads are secondary to the core suppliers of storage technology today, and have been for a couple of years, as a matter of fact. So what are we going to be seeing? 2 new classes of disk drives that, long and short of it, are tape-like. The pricing, the density, the capacities are increasingly tape-like. We see some of them, we're categorizing them as cloud and archive drives. There's plenty of 3-letter acronyms, shingled magnetic writes and heat-assisted magnetic writes and so forth. But fundamentally, lower RPM all the way down to 0. So spin down is finally designed into the drives themselves. It's not something that an array manufacturer attempts to put on after the fact, which has been proven to fail in the past. But look at those ratios, read-write ratios. Gone are the days of OLTP, 66% reads, 33% writes. That is a legacy, never to return the third platform onwards. What you do see in its place, rounding up, is 1% reads of these devices, not the network reads or the overall storage reads, including flash, just the disk reads, 1%, and 99% writes. So you're skeptical, hopefully, in the back of this room or in the middle or front of this room, asking yourself, how could the discrepancy be that large? Where, in the blazes are all these writes coming from? Petabytes, exabytes, zettabytes of writes. And we talked about privacy and Big Brother early on. Well, take out your phone. Take a look at your phone. Do this, please. Take out your phones and take a look at your phone. Your phone is looking right back at you. And what I mean by that is the vast majority of the apps you downloaded and quickly accepted the end-user license agreement on have embedded the permissions to use the selfie camera without turning the light on to track your eyeballs. And every single pixel coordinate that's extrapolated from where the app thinks your eyeball is looking, so on retina screens, this is a lot of pixels, every single pixel coordinate is a log entry, a write, on these disk drives. Billions, trillions, gazillions of pixel coordinates logged all the time. Of course, on your legacy devices, your laptops, your tablets, same thing, wherever the cursor is, if it doesn't have a camera, wherever the cursor is, that individual pixel coordinate in everyone before and after is logged, as well as when you navigate up and down the page, as well as when you click on next or checkout. Those are the easy ones to log. But every pixel coordinate in between is logged because, of course, everyone wants to assess how easy and graceful your experience on their websites is. And if it's awkward or cumbersome, you're not going to buy. You're not going to click on the ad. They want to improve that, and that's how they do that. Where do the reads come from, then, if we're pretty much all writes on the disk media, the hard disk media? Well, there's a whole alphabet of soup in the flash world. Flash has been fascinating to track. It's been moving extremely rapidly. Almost every year, a new acronym emerges in the flash industry. I spoke at the Flash Memory Summit about a month ago. A lot of interesting milestones reached. Perhaps one of the most confusing ones you're going to have to deal with over the next year or two, so please do pay attention, is that the roadmaps for the capacity of flash drives, of SSDs, have higher capacity than the short-term roadmaps of hard disk drives. Let me repeat that. Drives, which are supposed to be the capacity technology, are going to be smaller in capacity, for the next little while at least, than very expensive, very exotic SSDs and flash drives. But just because the short-term roadmap for flash has higher capacity than disks, do not confuse the price, which will still be roughly 10x difference between cost per gigabyte on a disk and cost per gigabyte at a higher capacity on a flash drive. The other thing to realize is that tapes and disks have been around for about 60, 50 years respectively. There's a really rapid half-life happening in the flash world. And one of our projections in NetApp Research, which is funded by the Office of the CTO, is that flash itself risks being a 10-year industry. Not 50 or 60 years, but 10. And we're 5 years into it, at least. So why are we so grounded, let's say? I wouldn't say pessimistic, because ultimately flash is solving some fantastic problems today. Why are we so grounded in our flash view? The manufacturing technologies to stay ahead of this game, to get into the 3D world especially, to be really current and modern in flash, are science fiction in terms of elaboration and complexity and risk. The CapEx to build a 3D fab for NAND flash is $20 billion. And not surprisingly, people with that kind of money are not feeling like taking a risk and making a mistake. They want to get it perfect after they invest $20 billion. So after, I don't know, I've lost track of how many years the supply chain for flash has spoken about 3D. Let's call it 4 years, especially as of this Flash Memory Summit. Of 12 global flash manufacturers, how many do you think are actually producing, shipping, selling, and supporting 3D flash drives out of 12? Anyone venture to take a guess? Glenn, yeah, 1. I think you're cheating, Glenn. I think you heard me say this before, but I'll give it to you anyway. 1 out of 12. Samsung. SanDisk, SK Hynix, Toshiba, Intel, Micron, on and on and on. All these really well-established, reputable vendors have still, after 4 years, not shipped a 3D flash drive. Why? Because they can't afford. It's a company-ending move to get this wrong. It's complicated, risky manufacturing technology. And it's only getting worse as the demand for capacity increases on flash technology. And the reason I emphasize that is that there's no such thing as a waterfall model where a vendor like NetApp takes technology from our suppliers, it's thrown over the wall, we qualify it, we integrate it, we package it, we ship it, and we sell it and so forth. There's a lot of joint collaboration going on right now. One of the dirty secrets of flash, and one of the reasons why we're in the era of diminishing returns from a manufacturing process, is on consumer-grade systems and low-cost flash drives, there's as much over-provisioning capacity hidden from the user as there is capacity visible and usable by the user. And that's because of all the endurance and wear issues that you've read about. They're all true. They occur to different extents depending on the cost of the flash media itself. The more expensive media, the less over-provision is required and so forth. And NetApp and Samsung in particular have collaborated, and we announced this at the Flash Memory Summit, on some new innovations, not just around physical capacity and packaging of overall flash solutions to get the rack density lower, but some of the really cool stuff if you're into storage engineering, which is how does I/O today really happen? It's the I/O blender. Most workloads today are virtualized or containerized. So by the time they actually go through a physical host storage controller down to physical storage media, you're getting a complete mishmash of reads and writes, completely randomized with random spikes, really hard to predict and manage. As a result of that, there's still been a lot of over-provisioning of enterprise storage arrays on a flash side to be safe, to make sure you never return an unexpected out-of-space message or an unexpected, the write failed message or some kind of things that enterprise devices just don't do. And some of the overhead, I think, in best practices, best in class, for an enterprise device have been 28%. NetApp and Samsung, on the engineering side, have collaborated to implement something called a multi-stream write technology. That's the engineering term. There might be a marketing term for it. The net effect is, on the next generation of Samsung and NetApp technology, you will take that 28% over-provisioning down to 7%. Because of how intelligently we're basically logging logs and we're recursing a bunch of virtual data writes down to physical. So there's a lot been written on this, a lot been published. We've actually worked with the ANSI Insights Committee for both SAS and soon SATA commands for all these things. They're ready on the high-performance SAS interface drives. And clearly, beyond the scope of this talk, we're going to be working on NVMe and NVMe fabrics to implement this over-provisioning savings as well. So let's get to probably the most mundane question I'm going to have for you today, which is, if you're still counting storage this way, what are your future storage protocols going to be? NAS protocols, SAN protocols, object, or are you really superseding the problem by thinking of it in a converged manner? So this can apply to all of Matt's categories. You know, converged platforms, converged infrastructure, or of course, hyper-converged. This is cool because this reflects a lot of the customer feedback I've heard over the past 6 months in particular. The hyper-converged trend, interestingly enough, not because of performance advantages, not because of scalability advantages, and not even because of price, because of simplicity. The complete pre-integration of everything, the easy button for deploying infrastructure, particularly at the edge, is why that trend is so popular. So there's a marketing term for hyperconverged, and then there's an engineering term. And unfortunately, you know, in those discussions, those debates, marketing always wins. But let me tell you what engineers called hyperconverged until recently. As I mentioned, there's a lot of frustration in the supply chain around the risk and extreme cost of manufacturing next generation of the flash. And I've had to dance around NDAs for about 3 years now with regards to, yeah, trust me, something is going to come next. It's going to ultimately replace flash, particularly on the performance tier. But I can't tell you about it. Can't tell you specifics about it. That all went away as of about a month ago. There's a very interestingly timed, very high-profile marketing launch by Intel and Micron jointly. And they announced something you should be Googling quite heavily if you haven't already, because it's going to change all of our lives. Very soon, remembering exponential progress. The first keyword to Google is a 3D X-point, 3D crosspoint, spelled 3D X-point. A week later, after the Flash Memory Summit, so this announcement was 2 weeks prior to the Flash Memory Summit. A week after FMS, we saw Intel's Developer Forum, another acronym, IDF. At IDF, they announced the Intel brand name for this category. So 3D crosspoint is a category of technology. And Intel's brand name that they will sell to us is Optane, O-P-T-A-N-E. Why are these going to change our lives? They're going to come in two flavors. The first flavor is going to be the fastest, wickedly fast SSD that will ever exist on the planet. It'll saturate PCI bandwidth. It'll have, you know, queue depths of 1 and maximum performance, and no tricks in terms of large queues to extract, you know, multi-tenant or highly hyper-threaded virtualized performance. But that's pedestrian stuff. That's PCI. That's, you know, your father's, your grandfather's technology. The very next version of this, also probably between 1 to 2 purchase cycles away, but again, I believe closer to 1 purchase cycle away, so not long, 3 or 4 years, 1 purchase cycle, will be a memory version of this. What this means is that you will now have memory at the price of flash. And one of the byproducts of this technology is, yeah, it'll get you 1 terabyte memory, you know, laptops, 10 terabyte memory laptops before the storage. It's at the price of storage. But one of the byproducts is it's persistent. It is storage. So for the first time in computing history, at least in a long time if you don't want to count vacuum tubes and things like that, you've now got a technology that unifies memory and storage. And you don't have obscure startups making bold, wild claims about this technology. It's the most respected manufacturing powers in the industry with the heaviest capitalization have made their big bet on this. It's not going to fail. This is too big to fail, literally. So one of the things you also have to internalize is that the math, again, matters from a latency perspective. In the tape, and especially the disk world, we focused on milliseconds. A state-of-the-art conversation about access latency on storage today is a microsecond level discussion. How many hundreds of microseconds latency does your flash system consistently deliver for high performance tiers for your various workloads? This now takes us into the realm of nanoseconds. Extremely rigid, extremely tight, almost impossibly tight timing. We're going to be talking about, and this is why I almost hesitate to use the term in the same sentence, the concept of storage, but let's really call it what it is, persistent memory that survives power, reboots, survives power outages, and basically returns data to us at nanosecond level speeds, at memory level speeds. This is what's upon us, which means that the controller for this new class of persistent memory is no longer an asynchronous PCI bus. Regardless of how big, wide, and fast it is a memory controller. It's a memory operation for persistence now. No more I/O asynchronously. It's a synchronous load and store operation, if you remember your computer science. So a whole branch of computer science is forming right now, which is what's so exciting about this. So a whole branch of computer science is evolving here around persistent memory programming. This is the part that's going to change our lives, because apps are going to fundamentally be different than they've ever been. Third and fourth platform apps. Lots of gobbledygook on this slide. I put the URL for you to pursue it later on, pmem.io, really easy site to remember. And they basically have this process they walk you through from crawling to walking to running with this new kind of persistent memory. Long and short of it is that the first killer app for this really cool technology is as simple as page files of virtual memory. Virtual memory will feel very real now, which is why you're going to see a lot of these odd combinations of very small amounts of expensive DRAM, which is still needed for caching metadata and so forth, with giant affordable spaces of persistent memory, 3D Crosspoint, Optane, and others it'll follow. And it'll be all at the performance, more or less, of memory, which will be amazing. You're going to see persistent memory file systems, because if I crash my process, or I have my server moved out from under me by some VMware admin, and I reload the process, reload the app, I don't go to load the data anymore. There's nowhere to load the data from. It's already in memory. But where is it? I need to start tagging it, naming it, a namespace for it. And finally, actually, before we get to the next survey question, the coolest mode is actually something called direct I/O, or user mode I/O. And that's where you're not even incurring a context switch. Remembering now in computer science that going from user mode to kernel mode in an operating system incurs a certain amount of overhead, a certain amount of latency. When the memory, the persistent memory, the storage effectively is that fast as well, that context switch is a huge bump in the wire. It's overhead. So access modes with modern, brand new APIs for doing everything from user mode, just like Oracle DNFS today, which from 10 to 11G to 12C has now become the default I/O mechanism with Oracle. User mode I/O has a huge future. So now that I've unleashed a whole bunch of this new technology upon you, which of these databases are you actually seeing the most growth in within your own enterprise? And I hope it's not just H. Because that reorg that Matt talked about may be a surprise to you if it is. Lots of Hadoop going on. It's got to be Mongo, trust me. You should find it if you don't know where it is. So Hadoop, that makes sense. All of these are in our future, by the way. We're not escaping any of these. These categories, regardless of the logos and vendors and all the M&A that's inevitable, Oracle or Microsoft will own them all someday, but these categories are here to stay. So I mentioned this earlier on, a bit out of order, but what we're doing in NetApp research that we've already proven with open source contributions is we are contributing code into the databases and file systems of the future, because you can't now have a driver that has all those context switches, either at the hypervisor or even at the host kernel level. So 3 last concepts I'll leave you with that you're going to have to really reassess and relearn: scale up, scale out, and in-memory. I think the latter 2 are fairly well known and understood today. In-memory equals fast but volatile. That's going to change. It'll be fast but persistent in the future. Scale out and scale up are interesting, though. Today, the model for adding more performance or capacity is just to scale out. That's the economic model. But when the individual nodes now can have a petabyte of RAM on a data center blade, I think the need to scale out is going to be diminished for a lot of workloads, and the new generation of scale up will be upon us. Not the IBM mainframe style, not the HP Superdome style, but big, dense Intel racks, x86, maybe AMD racks as well, is going to be a huge performance third platform and fourth platform model going forward. And quickly, there's a border you're going to have to architect in 2020, so this is somewhere between 1 and 2 purchase cycles away. That border is the 1 microsecond border. Anything below that border that is slower in latency than 1 microsecond, which is every flash and every disk-based solution, or hybrid flash disk solution today, that's the shared storage. Your single source of truth, where the lawyers and auditors and regulators come to find out what's really going on in your company. But everything above the border that's faster than 1 microsecond, so the nanosecond class speeds that Intel and Micron announced, that's where the primary and secondary copy of data lies. That's where the premium storage is, if you still want to call it storage. I will call it persistent memory until someone corrects me. So let's talk about an interesting use case now as we wrap this up, and how all these cloud economics are going to be leveraging these new technologies, maybe ahead of when you can adopt them yourself. I tend to summarize cloud in just 2 slides. And I've been studying this for way too long. I got lucky and called this trend early on. And it's come down to, not everyone's opinion. It's outsourcing or efficiencies or lower cost or slower WAN performance or security risk. It's about 2 fundamental things. First one is making money. New incremental revenue streams, brand new valuation, not fake valuation. So Bessemer Venture Partners used to be one of my neighbors in Menlo Park. Is a very smart firm. They publish, I think, either monthly or quarterly, their cloud index of the actual publicly audited, because these are public companies, valuation of born in the cloud or cloud-native apps and companies. And their conservative estimate for all listed companies is 176 or 178 maybe $billion of brand new valuation enabled by the cloud. This doesn't even include Facebook. This doesn't even include, private companies, as we've talked about, like Uber, Airbnb, that are $50 and $40 billion respectively. So my estimate is to date, starting when they started counting in 2012 to date, there has been $400 billion of new business value created by the cloud. That's why we're all talking about it. We'll talk about the details and technicalities later, but enormous new business valuation created. The second critical thing to track, and a firm called the 451 tracks this, is something called the Cloud Price Index, to complement the Cloud Index. And that's the operational cost of running all these apps, all this cool technology like Uber and so forth. And what they do is they dissect from the various popular public cloud services what some of the high-profile line items that you see discounted regularly and you think there's a race at the bottom. That's some of the prices that are in the dotted blue line below. The reality is the vast majority of the very cool proprietary services that all these cloud vendors provide to developers and entice them and seduce them with these wonderful environments, those do not get discounted in price very aggressively at all. So many myths should be shattered here. Cloud is not a race to the bottom. And I think if you've seen the AWS financial reports and a 24% operating margin they have, which equates to something like an 80% gross margin for their services, that ain't cheap, folks. That's way more margin than all the storage vendors charge today can get away with. So cloud is not cheap. How do we apply this to the enterprise? This is where we're going to wrap it up. We've had an analyst firm called Gartner, which you all know, do this survey that's 6 years in running, going to be 7 years soon once they publish 2014 results. Very similar categories and roughly similar math to what Matt showed us earlier. This is not the IT budget question. This is the tech spend question across all lines of business. 14% of it, global average, so it's higher in the US, 14% of it is spent on those ambitious business transformation initiatives. How to reinvent yourself as a company, how to not get Uberized. 20% is double down on things that work. So VDI, you want to make a really complex business workflow for your knowledge workers mobile. You do VDI, you do application delivery. That's a 20% bucket. And that last 66% is keeping the lights on. So life cycles that Matt talked about are really critical to what the hybrid cloud will be. And I'm just simply remapping those 3 categories into a life cycle. Now we focus on dev test, deployment, and maintenance as the 3 milestones. And you can do this waterfall style with very, very long and slow cycles for each and big milestones between each, or you can do this continuously in an agile process that works the same. And we see an interesting conclusion if we talk about the cloud now. And this is a really important report that was released by IDC recently, based on 2014 surveys of enterprise users. The small majority today, but is the majority of users, move their data off public clouds. Why? Because of cost and quality of service primarily, but there's lots more detailed data in this report. So let's take a break now and actually ask you which model you're using before I'll show you what the industry in general is doing with regards to hybrid cloud. So are you using primarily public cloud as your strategy, private or hybrid? That is true, and this is very reflective of what I see. In my mind now, there really is only one practical cloud model, and that's the hybrid model. And everything else, public and private, are subsets of the hybrid cloud. So here's why. If you map those 3 stages of the app lifecycle or project lifecycle into the categories of hyperscalers at the top, tier 2 service providers, the OpenStack style providers, over on the right-hand side, and finally, the end of the cycle, if you will, hosting sites or on-premise, you basically see that those are 3 kinds of economics right now where elasticity, that really prized attribute of public clouds, is extremely valuable during that upfront dev test cycle. For test, it's unbeatable. You can never test at scale the way you can on Amazon or Azure. So that's fantastic. But as the workloads stabilize, as the workloads become predictable, the value of elasticity diminishes greatly. And now you just need quality of service and price for a well-defined, well-parameterized workload. And that's where these other service providers come in. They offer better price for the stable workloads that have already been innovated and developed on Amazon, better price for those workloads as they age. And finally, most of these really mature vendors, Workday, NetSuite, Salesforce certainly, and so forth, their cloud apps are already legacy. They're in maintenance mode, many of those modules. So you really understand the workload by then. You really need to squeeze all efficiencies out of those to leave room, time, and money and people for innovation. And so you continue to migrate those workloads off to the most optimized infrastructure that's the least elastic, which can be as simple as traditional IT environment today. I actually go so far as to say that if you don't deploy hybrid cloud in this way, if you don't innovate in the public cloud, you are you're actually exhibiting professional malpractice. Because the ability to innovate in the public cloud now is something all of your competitors are doing. And they are iterating quicker, they're doing fast fail quicker, but they're getting to those functionalities and those workflows that actually resonate. So it's really a mandate now to innovate in the public cloud, but to deploy the way a traditional enterprise would with tier 2 hybrid cloud solutions as well as on-premises. And that's exactly what NetApp's Data Fabric is all about, in case you were curious. We don't really talk about our portfolio as having hardware solutions, filers, and controllers anymore. Every rectangle you see now, aside from the open source ones over on the right, that we don't obviously create, we just support them, all the blue ones are virtual controllers. Any one of them can be deployed on our hardware, on your hardware, or in a service provider's environment on their hardware. Sometimes we don't even know what the hardware is. And as Matt said, you can deploy as many of those virtual controllers for performance and capacity at any time as you need, and decommission them as you need to decommission them as well. So this is literally a 100% shipping and supported software-defined portfolio from NetApp today. And the mobility of all those workloads, Snap Mirror, for example, is heads and shoulders, leaps ahead of rsync and FTP, which is state-of-the-art in data mobility in the cloud today. So by having virtual controllers at all the right endpoints in a hybrid cloud, you can enable the visibility, the control, but especially the mobility of those workloads to follow those economics. That's fundamentally what it's all about. Last slide, I promise. This is fundamentally how to be a Jedi Knight at hybrid cloud. Because those of you that have spent time moving a lot of data know that data has enormous gravity. It's really hard to move, always more data than network capacity. And when you deploy something called NetApp Private Storage for the cloud, and this supports almost every major cloud now, Amazon, Azure, Google, Oracle, GovClouds, and so forth, you basically put your data centrally, strategically in between all these cloud providers. And so as Matt said, owning your data and renting the compute resources is the most advanced model going today. Because you can arbitrage between your public cloud providers on price, on functionality. You can easily migrate workloads just like vMotion did in the VMware days without moving data. And this has actually been available and supported for 3+ years now. It's the most mature thing we sell. As we do typically at NetApp, we tend to start with the most advanced thing first and then work back towards the most simple thing, which is cloud ONTAP and so forth. But this is something that's definitely deployable today. If you want to find out more, please join us next month in October in Vegas, or if you're European, in Berlin in November. And with that, if I have any time, I'll take questions.
We definitely have time. Great big hand. All right, well, thank you. There we go. Oh, you did go. I just wanted to make sure you knew you got it right on time, so you got everything in. We're all good. We are looking for questions. Looking for questions for Val. Oh, sir, I'm sorry. I didn't see you right here. You go.
I hope I've given you enough meat to chew on.
So a pretty basic question. Of the 14% of the innovators that are, kind of going out there, where are the things you talked about, or what are the top 2 or 3 things where you see kind of a critical mass forming where customers are going there?
That would be really easy. It's things like using Amazon S3 and using a Mongo instance or using their Lambda development environment and so forth, just to be able to simply prototype a new workload or a new piece of functionality. And it's following fast-fail principles. So it takes you days, sometimes hours, for really good developers to prototype a new workflow. You can put it out there to thousands and millions, if you want to, of users for testing. You can find out statistically through analytics. You don't have to ask anyone which workloads are actually running through from beginning to end, which ones fail halfway through a process, which ones people are actually willing to pay some kind of artificial value for. There's a lot of testing you can do in a very scalable, automated way very quickly. What tends to happen is after you use a lot of very productive but proprietary Amazon services, for example, to put together this prototype, 1 out of 10 modules actually is successful that you actually want to fund and deploy and scale. This is the hard part. This is where a lot of money is to be made by developers and DevOps folks, because you typically have to decompose those proprietary Amazon services for databases, for messaging, for name services, for querying, for just workflow coordination. You have to decompose those into their open source equivalents, and there's always a one-for-one mapping or one-to-many mapping in terms of many open source projects to emulate what Amazon does, and then orchestrate those open source components, typically using an OpenStack style orchestration process. So there's a lot of art to that right now. There's no one button click to implement that, but that is a scale process. And once you've done that architectural work, you can now afford to deploy any of those workloads at any scale you want without the compound ongoing tax that an Amazon would charge you for just using their easy button to, charging 80% margin basically to run a stable workload. So that's the process going on right now. Every icon on your phone is there because it's reached a certain level of popularity. Every single one of those icons has gone through that process of prototyping on an Amazon, and all the things that scaled that really ended up being popular. Most of those are now in either other data centers or the company's own data centers, because that's where the OpEx works.
Excellent. Can we get one more in real quick? Anybody, one more? Yep, right over
Val,
here.
Rob Flannery, real quick, if you're a NetApp customer today,
Yeah.
and whether it's a big environment, small, and you're growing, what are some of the things that you should be considering in building towards or considering now in the portfolio that will make that next migration easier?
Absolutely. Great question. And I'm going to go back to one of the recent slides I had here, if I can go backwards, so we can use this one. If I'm at the edge of my enterprise, I look at one of these converged or now hyper-converged solutions. I don't have the luxury of time or the expertise on site. I call it the hoodie index, the number of hoodies you might have in your office, right? In San Francisco, it's high. Everywhere else is pretty low. So I don't have enough hoodies to actually integrate all these technologies I need to operate my business at the edge. I'm going to look towards pre-configured, pre-sized, pre-tested, pre-installed, converged or hyper-converged solutions depending on the size and scale of my workload. On the other hand, if I'm at the core, I am really doing some cool architectural work right now because I am not bound by any limitations of hardware anymore. I can deploy all the IOPS on all the capacity I need with any combination, mixing and matching of virtual software controllers as well as physical controllers for predictable workloads and so forth, predictability, et cetera. So this is now, I would say, developers' playground in the public cloud and an architect's and operator's playground in the core of the data center, where it is fully software-defined right now. And whether it's object with storage grid, whether it's streaming workloads, which is beyond just backup and archive with AltaVault, or traditional block and file workloads, all those now are available in virtual as well as physical forms.